Welcome back. All right, so now we're going to graph the same transformation, but for f of x equals the cube root of x. I have this one already on my already graphed the parent function. You don't have the parent function graphed on yours, I do not believe. So you want to graph the parent function. The points are right above. They are 0, 0, 0, 1, 1, and 2, 3, 4, 5, 6, 7, 8, 2. Right? Those are all, so the -8, the -1, the 0, 1, and 8, they're all perfect cubes. And we have -1, -1, and 8, 2. So 2, 3, 4, 5, 6, 7, 8, 2. All right, so you want to graph those points. And we're going to do the very same transformation. All right, so we're going to graph the cube root of x plus 3. And just like before, it's just going to move our points up 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Notice you never want to just graph those 3 points in the middle there. They always form a line. No matter what kind of transformation there is, they always form a line. 1, 2, 3. And there we go. And so the cube root has this kind of elongated S pattern. It is the inverse of the cube. And there's our function. Now, domain and range are super easy on the cube root function. For any cube root function, it's going to be all real numbers. Just like the cube has domain and range, all real numbers, so does the cube root. Oh, and we forgot to do the other graph. Let's do the other graph, and that is the cube root of x minus 4. It does still have the same domain and range, but we didn't graph it. 1, 2, 3, 4, so we'll just shift all our points down 4. And then we have the cube root of x minus 4. And there it is. Look how easy that was. So we're just going to always graph our base function and then translate, and we can't go wrong. I kind of missed my point there, but just a tad, but that's okay. All right, let's go look at the next one. And change my page. All right, so this was the horizontal translation, first with the square root function. All right, so this one is going to shift to the right. Oh, you know what I didn't do on the other page? Let's take care of that. We didn't write the equations. All right, how will the graphs know who they are? All right, so this one was y equals the cube root of x plus 3, and the green graph was y equals the cube root of x minus 4. Now on to the next graph. All right, so I'm going to just shift this graph to the right. Right? And so we're shifting these points 0, 0, 1, 1, 4, 2, and 9, 3. The ones that are listed up there. Those are our key values. If we had more space, we could also graph 16, 4, but I'm starting to run out of space. So 2 to the right. 1, 2, 1, 2, 1, 2, 1, 2. And if you looked at the graphs of the people that did the horizontal translation, you saw the same kinds of graphs. All right, so, and you saw the same transformations in the graph. So this is y equals the square root of x minus 2. And now let's graph y equals the square root of x plus 1. So that's just going to move 2 to the left. So all our key values are just shifted over 2 to the left. And it's a little busy in here because they're all really close together. Y equals the square root of x plus 1. Let's do the domain and range. All right, so we have different domains and different ranges. I'll just make them color-coded. All right, so for the first domain, we're going to do the blue graph, y equals the square root of x minus 2. Notice it's shifted 2 to the right. All right, and so since it's shifted 2 to the right, the smallest x value we used was 2 to infinity. The arrow means it's going to keep going. Let's do the domain of the red graph, y equals the square root of x plus 1, and then we'll talk about the ranges. Right? So the domain of that graph, we shifted 1 to the left, so now we can go through negative infinity, and our starting value is negative infinity to infinity. So notice it's really easy to spot. See, there's your starting point right there. It has that kind of key value. So that's going to be the start of your domain and your range. Here's the starting value for the other graph. That's the start of the domain and range for that graph. Now the range is the same for both those graphs. Notice they are on the y-axis, which means our smallest value, on the x-axis, which means our smallest value of y was 0. So 0 to infinity. Since we didn't shift it up or down, we didn't change our range. So on the square root, if you shift it right and left, you're going to change the domain. If you shift it up and down, you're going to change the range. Let's do the same transformation, but with our cube root. Right, so our key values right there, and we have those 5. I can't find where 8 is. 2, 3, 4, 5, 6, 7, 8 right there, and then 2, 4, 6, 8 right there. All right, so same shifting. All right, so y equals the cube root of x minus 2 is going to shift 2 to the right. So I'm just going to shift all of those points 2 to the right. Come on, 2 to the right. 2 to the right, and we missed him. Here's 1 right there. 2 to the right. He should go right there. And 2 to the right. All right, so now here is our cube root. Looks like it's going over the other graph, but it's really not. They're just kind of going really close together. All right, so there's the graph of y equals the cube root of x minus 2. Let's do the same thing, but now it's x plus 1. So everything moves 1 to the left, 1 to the left, 1 to the left. Oh, him right there, 1 to the left, and 1 to the left. And in such a small space, 3 graphs gets kind of crowded. There's y equals the cube root of x plus 1. And it doesn't matter what you do to a cube root function. Its domain and range is all real numbers. And there we go. There are the 3 graphs, and you can see them being shifts of one another. Okay? So we didn't do cube roots in class. We're just extending this to cube roots, but the rules are the same. Y equals 6 square roots of x, and y equals 1/2 square root of x. So now all we're going to do is take our values, and we're going to change our y values. Not the x's, just the y's. Keep the x's, and we're going to make the y's 6 times as much, right? Because we'd be taking the square root, and then we'd be multiplying by 6. So here we have, so this is y equals the 6 square roots. Let's just take this and make this y equals 6 square roots of x. So to make that y equals 6 square roots of x, I'm going to take all those y values and just multiply them by 6 because they're going to be 6 times as much. Oops. All right, which means we'll have the same x values, but our y values will now be 0, 6, 12, and 18. And you can tell I'm not going to graph some of those. I can get the 0 and the 6, and it may be the 12 if I don't mind drawing it off the page a little bit. All right, so here we still have 0, 0, and then 1, 2, 3, 4, 5, 6. Look how fast that's growing. And you saw that if you looked at the vertical stretches, how quickly they grew. And then we had 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I can fit that one in there. And that's the last one. So look how fast that's growing. That really makes a difference, huh? That's a big old vertical stretch. So now we're going to have a little compression. And so now instead of multiplying by 6, we're going to multiply by 1/2 to graph y equals 1/2 square root of x. So if I multiply 0 times 1/2, it's still 0. And 1 times 1/2 is 1/2. And 2 times 1/2 is 1. And 3 times 1/2 is 1 1/2. Look how slow this is growing. Let's add some more points. So the next one would have been the square root of, oh, except I can't get it on the y. Oh, never mind. I was thinking, I got lots of space for more points. I have lots of space on the y, but I can't fit them on the x. So we'll just have to graph those ones because I can't get 16 in. All right, so we have 0, 0. Look how slow this one's going to grow. So 1/2. A big old whopping 1. Say 2, 3, 4, and 1. And then 5, 6, 7, 8, 9, and 1 1/2. So look how slow this one's growing. Oh, it's going to take all day, right? Because each time we're only taking 1/2 of the y value. And so this one here, the fast-moving y equals 6 square roots of x. And here we have the very slow y equals 1/2 the square root of x. All right, and you can graph those. And guess what? The nice thing is our domain and range didn't change. Notice they are all have the exact same, actually let's do it in red. They all have the exact same starting point right there at 0. So the domain is going to be 0 to infinity, and the range is going to be 0 to infinity. Even though that y equals 6 square roots of x is growing faster, they're still moving right along, and they'll eventually get to, they can't reach infinity, but you're going to just keep growing. One of them is just doing a little faster. And that's the same thing with the cube root function. All right, so you need to graph your parent function. I have mine up here. So 0, 0, and 1, 1, and 2, 3, 4, 5, 6, 7, 8. And you know, I didn't say this, but it goes without saying, I guess. 4, 5, 6, 7, 8. That if I'm going too fast, because I have things drawn up here, and you're trying to write things down, just pause me. All right, so let's graph this one, and we're going to have to multiply our y's by 2, or 6, and then by a half. All right, so I'm just going to use the same one over here, and I think you have it in your notes. So this will be 6y. So then if I multiply by 6, this one's going to be negative 12, and negative 6, and 0, and 6, and 12. Right? And if I multiply by a half, all right, this one would be negative 1, and negative 1/2, and 0, and a half, and 1. All right, so now let's graph these. All right, so we have the point 0, 0, and then we had 1, 6. So 2, 3, 4, 5, 6. And then we're going to have, so I have to look across here. So now it's going to be 8, 12, right? 8, 12. So 1, 6. So don't forget, these are our x values. Kind of started in the middle here. And then we have 8, 12. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, way up here. Then on the other side, we're going to have negative 1 and negative 6. 2, 3, 4, 5, 6, and then negative 8. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So look how fast this one's growing. Here we go. This were a roller coaster. This would be a really high roller coaster. There we go. So this is the graph of y equals 6 cube roots of x. All right, so look how fast those values are growing. And then we have the slow-moving 1/2. All right, so it has 0, 0, it has a half, and then it has 1. Poor little function. Look how slow it's going. So here is the red one there is y equals 1/2 cube root of x. Look how much slower that one is. All right, but it doesn't matter what you are, what kind of cube root function you are, your domain and range are still the same. And there we go. I was hoping to finish this, all this up, and then move to the multiple transformations. We'll see. All right, let's see if we can do this one. So now if we multiply, on the other one we multiplied the y's. On this one, we're going to multiply the x's, right? So it's going to be the x's that multiply. All right, so, and actually this one is just a little bit trickier than some of the other ones. Actually, you know what? In the interest of time, let's do this one and the next one in class. Let's do these two because they're super easy, all right? Because this is my second podcast. So I like to keep it to about no more than a half hour, and I'm getting close on that. All right, so let's graph y equals negative x and y equals negative square roots of x and y equals the square root of negative x. All right, so the first graph is going to make all for the first equation, y equals negative square root of x, it's going to make all our y's negative, right? Because I take the square root and then I multiply by a negative number, I'm going to get nothing but a bunch of negative numbers. So we're going to have the exact same points. They're just going to be flipped over on this side. So 1, 2, 3. And so here we have y equals negative square root of x. All right, so let's do the same thing, but let's graph y equals square root of negative x. So now I can only plug negative numbers in, right? Because I have to take the square root of a positive number. So if I plug in negative 4, for instance, right, that makes it y equals the square root of 4, which is 2. So now I can only plug in negative numbers because of that negative. And that's going to reflect our graph over the x-axis. So instead it's going to look like this, 0, 0, 1, 1, negative 1, 1, and then negative 4, negative 2, and then 5, 6, 7, 8, negative 9, 3. And so here is this graph. Y equals the square root of negative x. Right? So now they both have different domains and ranges. They both kind of have this as their starting point, right? But they're kind of going in opposite directions. So for the blue graph, the domain is going to be all of our positive numbers, 0 to infinity. For that green graph, our domain is going to be all the negative numbers, negative infinity to 0. Right? For our range, right, we're flipped over the x-axis, so we have nothing but negative y's. So we're going to be negative infinity to 0. So 0 is our top value. On the other hand, for y equals the square root of negative x, the y's were still positive, just the x's were negative. And so this one was 0 to infinity. Just interesting how their domains and ranges are opposite. Let's graph the same function, but the cube root. All right, so here, same kind of idea. We're going to have all of our x's. On the first one, we're going to have all of our y's be negative. All right, so instead of, well, 0 won't change, right? But instead of 1, 1, it will be 1, negative 1. So we're just going to be reflecting over the x-axis. This one's like a little bit crooked here, because this one here should have been a 2, 3, 4, 5, 6, 7, 8. This should go through 2 right here. So kind of missed my spot there. All right, so this will be flipped over onto the negative side. All right? And then instead of negative 1, we're going to have negative 1, positive 1. And instead of 2, 3, 4, 5, 6, 7, 8, this is going to be over here on the positive side. All right, so this will be our graph. All right, so now let's do the same thing, but now we make the x's the negative, right? And we're going to keep the same, reflecting over the, the y-axis. So first we reflected over the x-axis, now I reflect over the y-axis. But will our graph look any different? I don't know, let's find out. Cube root's kind of interesting, huh? All right, so let's make a table of values just so we can see this one, all right? So y equals the cube root of negative x, all right? So if I plug in negative, so I'll plug in negative 8, right? So if I plug in negative 8, I'm going to have the cube root of negative 8, which is going to make it positive 8, all right? So that's going to be 2. If I, why would I put 8 up there? That's supposed to be x. This is x and y. And let me just make that clear, that this here was y equals the cube root of negative x. All right, and then we have the cube root of negative 1. Right, so that would be a positive 1, so that's going to be 1. And then the cube root, negative 0 doesn't have any meaning, that's still 0. And then we have the cube root of negative 1, because we're plugging in 1, so that would be negative 1. And the cube root of negative 8, that'll be negative 2. All right, so we plugged in negative 8, and we got positive 2. And that's right there. Huh. Well, that kind of matches up, doesn't it? We plugged in negative 1, and we got 1. We plugged in 0, and we got 0. We plugged in 1, and we got negative 1. And then we plugged in 8, and we got negative 2. Now, isn't that interesting? That because you can take cube roots of negative numbers, they're the same graph. That doesn't happen too often. So, and it doesn't happen for the square root. So here's where it breaks a little bit. Y equals the cube root of x is the exact same as y equals negative cube root of x. Because when it ends up, because it's symmetric like that, and when I am flipping over the x-axis or I'm flipping over the y-axis, it looks exactly the same. Only for the cube root, though. Its domain, however, is all real numbers, no matter what you do to end range. All right, so we're going to stop here, all right, and then we're going to go back to this the graph that we skipped, which is this one back here and this one, and we'll do those horizontal stretches. And then we're going to move on to multiple transformations. All right, thanks for watching the podcast. Bye.